Let's look at lesson 2.7, calculating rate of change from multiple representations. Rate of change is slope. We've already been working on finding slope, but let's apply it a little bit more to real life, looking at some real life situations. So in order to be able to do this lesson, you're going to need to be able to calculate the change between y values and x values. Write it as a ratio to represent slope of a line, and still distinguish between zero and undefined slopes. So none of those success criteria change. The only thing I would add is that we need to be able to take information from a word problem and apply it to real life, right? And apply it to, okay, can we find the slope, okay, for situations. So when looking at it for a table, let's read the situation. A biology class planted a bean sprout and monitored its growth over several weeks. The table below shows the change in sprout's height over several weeks. Find the average growth pattern in the height of the bean sprout. Be sure to include units. So when it says find the average growth pattern, we're looking to find, okay, how much is it growing per week, right? How much is it growing per week? That means we're looking for slope. Slope is a unit, or the rate of change is the amount it's changing per one unit, and whatever our units is. So for this case, we're looking to see how much is it growing in 1 week's time. Whenever we see a table, we know how to find slope of a table. From a table, we look to find our change in our y values divided by our change in our x values. So I'm going to do that here. From 2.4 to 2.9, it looks like it had a growth of 0.5 inches. And that was in 1 week, right? That was from 1 week to 2 week. I also noticed that it's the same for the second to third week. It still grows half an inch. And if I look for the last week, from week 3 to 4, it is still growing by half an inch. That means, on average, and since it grew the exact same amount, right, each week, the average is the amount it's growing by. So I can put my change in y over my change in x and put 0.5 over 1, which is going to simplify to 0.5 as our slope. And we're almost done, but let's look at it in terms of what it means for the problem. Because our answer, or our question, asked us to include units. So what does this mean? Well, it's asking us to find the average growth pattern. Let's write what that means in words. On average, the bean sprout grew half an inch, or 0.5 inches, per week, or each week. Either of those things will do the same. And that's telling us the rate of change or the slope. So that would be my answer in a real life context. Let's look at the question number 2 from a graph. A savings account balance can be modeled by the graph of the linear function shown on the grid. Find the rate of change of the balance with respect to the number of deposits. Be sure to include units. The key thing from this example is, one, to note that there is a graph. And then it says find the rate of change. Rate of change is a another way to say slope, right? So we're just looking for the slope. So how can we find the slope of a graph? Well, we can count rise over run, or I can also identify 2 points. Their ordered pair, and make a tiny table, or use my slope formula. I think I am going to make a tiny table, because what I notice is that my y-axis, I'm not counting by ones. And when I'm not counting by ones, it's super easy to make a mistake. I can't just go, 1, 2. Because notice, here I'm at 50, and I go up to 150. Well, that's not an increase of 2, that's an increase of 100. So to make sure that I don't make that mistake, I'm just going to write an ordered pair. I'm going to choose 2 points. Doesn't matter which ones. I'm going to choose these 2 that are closest together. That means I'm not going to have to simplify. And I'm going to say my ordered pair is 0, 50. And then this one is 1, 150. And now I'm going to make a tiny table. 0, 50, 1, 150. And look for the increase. We already said that was plus 100, and this is plus 1. So the change in y over the change in x. 100 over 1, which is going to get me 100. So my slope is 100. Well, what does that mean in terms of the problem? Okay, and let's look at what it would look like if we were to do rise over run. Because when we see a graph, we can do rise over run. I'm going to go up, but I'm going to note that I'm going up by 100. Then I'm going to go over. I'm counting by ones there, so that's just plus 1. Rise over run, so 100 over 1, which is still going to get us a slope of 100. All right, so slopes are the same no matter which way I do it. I just have to make sure I know what I'm counting by on my x-axis and my y-axis so that I don't make a mistake. Slope is not 2 over 1 or 2, okay? Now back, what does this look like in words? Well, it actually tells us in the problem. It says the rate of change of the balance with respect to the number of deposits. So let's look at this. The number of deposits, and then it's the balance in the bank account. Well, this tells me since my change in y is on top, that's my money, right? That's my balance, and that's the number of deposits. So this tells me that there is $100 added to the savings account per deposit. Okay, or $100 more in the savings account per deposit. So each deposit, there's going to be an increase of $100. Now let's look from 2 points. 2 points, we know we can use a tiny table if we would like to help us out. Let's read the problem. After 30 baseball games, A-Rod has 25 hits. Then after 100 games, he had 80 hits. The ordered pairs are 30, 25 and 100, 80. Find his average hits per baseball game. Be sure to include units. So again, we're looking for the average hits, okay? We're looking for how many hits is he getting per game. So we're looking for slope. I'm given the ordered pairs, so I could use the slope formula if I wanted to. I'm going to choose to make a tiny table on this one. Now, if you want to use the slope formula, go for it. Label 1 is 0.1, 1 is 0.2, and plug them in. Now, I'm using X and Y, but I actually am going to go back and I'm going to erase it. I'm going to label it with what it is. What are we actually talking about? Now, they represent X and Y, but what is it really? Well, this is 30 games, right? And then 25 hits. And then he had 100 games and 80 hits. So I'm looking at games and hits. It's X and Y, but he can't have any hits if he's not playing in any games. So hits is dependent on the number of games he plays in. And we're just assuming probably going to have more hits if he's playing in more games. So let's now find our change in Y. From 25 to 80, that's an increase in what? 55. And from 30 to 100, that's an increase in 70. I'm going to divide 55 by 70 because it's the change in Y over the change in X. Okay, when I plug that into the calculator, I'm going to get a fraction of 11/14. And what that tells us is he is getting 11 hits every 14 games. Since my Y value was on top and my Y was my hits, my games was my X. But if I wanted to write that as a fraction per 1, It's looking at he's getting less than 1 hit per game. He's actually, if we write it as a decimal, he's getting 0.786, give or take, roughly, hits per game. I'm going to write it just in terms of the pretty number 11/14, which tells me that every 11, or he gets 11 hits every 14 games. So in 14 games, A-Rod will get 11 hits. Now I know hits was on top because hits was my Y value, right? And 11 is on top and change in Y is on top. Or 11/14 hits per game. Let's look at this last one. The average blue whale gains weight at a constant rate each day during its first 6 months of life. The relationship between the average blue whale's weight in tons and its age in days for the first 6 months of life can be modeled by the equation y equals 0.01x plus 3. Find the average weight of the blue whale gains each month. Now, when we're looking at average weight, we're again looking for, okay, how much is he growing per month? We're looking to find my slope. And this is from slope-intercept form, an equation. Well, the formula for slope-intercept form is y equals mx plus b, where x is my independent variable and y is my dependent variable. B is my y-intercept, and we'll talk more about this later, guys, in our next unit. And m is my slope. M is always my slope. X is never my slope. It's always m. So for this problem, all I'm doing is looking for what number is in front of x. 0.01 is, so my slope is 0.01. Well, what does that mean in context of the problem? Let's go back and look. The relationship between the average blue whale's weight in tons and its age in days. We're looking for the average weight it gains each month. If the slope is 0.01, then that means that my whale gains, and it says weight in tons, an average of 0.01 tons per month. All right, take a look at these problems. Let me know if you have any questions about how to look at them and get started on the practice.